Hey everybody, how's it going? My name is Attila, and in this video I'm going to show you how to use select for update to solve concurrency problems when you work with Postgres. Let's consider the following example. So let's say we have a table called accounts and it has two columns. So we have an ID column, we have a balance column. This might be part of a financial application or some sort of application where users can store money, so they have accounts and balances. So we inserted some simple data. We just inserted one row with a balance of 100. So we can query this row, and as you can see, this is the result. So what I'm going to do now is create a new transaction. So we create a new transaction, and then we're gonna query the current value. And then next, we're gonna pretend that we have some application that has some business logic, and let's say that it checks if the balance is greater than or equals to 100. And then if the answer is yes, then we can update the row and we can basically subtract 100 from the balance. So it's like you spend 100 or you just withdraw 100 from an ATM or something similar. And then if we actually do the update and then we commit the transaction, we query the table, now we query the same row. Now we see that the balance is 0, which is the expected result. So this is what happens normally if you only have one client that makes requests to the database. Obviously, in practice, you will have multiple clients that make requests to the database, and some of those requests will happen at the same time. So let's see an example where we have two transactions, and both transactions are trying to update the same row. All right, so let me open two SQL scripts. So I'm going to open transaction A, and I'm going to open transaction B. Let me pull this to the side. So now we're gonna have two transactions here. Transaction A is this one, and then transaction B is this one. And they both will try to update the same row. And so let's try this and see why this could be an issue. But first, reset the table. So I'm gonna just truncate the table, insert the same row. So I started transaction, I query the current value. And the idea here is that I might have an application that checks if I have enough money on my balance to satisfy the request. In this case, we're just going to subtract 100 from the balance. And so first we are selecting or querying the balance, and then we update the row. And we are doing this from two transactions. So let's do that. So let's also start transaction B. Let's also run the select statement there. And then now I'm gonna update transaction A, and then I'm gonna commit, or actually we can update the other transaction as well. So I'm gonna update transaction B as well. Now what you notice here is that the query is still running. In this case, if you are running update, it will actually put a lock on the row, so you won't be able to update it from another transaction. Basically, transaction B is waiting for transaction A to finish, to complete. So let's do that. So I'm gonna finish or commit the transaction. Now you see transaction B has also completed, or sorry, not completed, the update statement completed. And if we go here in transaction A and see the results, so we actually query what's in the table now, we see that the balance is 0. Now the problem is, if we commit transaction B and now we run the same query, we see what the balance is. Now it says minus 100, which is not good. This is not the expected result. So that's the problem right here. How can you solve this? There are multiple ways to solve this. I'm going to show you one way, which is to use select for update. So let me, again, reset the table. So we're just gonna truncate it, insert the same row. And what we're gonna do now is we're gonna modify the select statement here in actually both transactions. So we're gonna go here and add for update. And we're going to do this for this select statement as well. And what this will do is it will basically lock the row after you run this statement. So previously, the row got logged only when you actually ran the update statement. Now we will lock it even after the select statement, which is what we want to achieve, because in between those statements, in between the select statement and the update statement, we have some application logic that needs to decide if we can update that row. And so we are locking the row. So let's see how it works. So we begin the transaction. We can also begin transaction B. And now I'm going to run the select statement. So now we have logged the row. And you can test it by basically trying to run the select statement in transaction B. And if you do that, it's you can see it down here that the execution is still ongoing. So basically transaction B is now waiting for transaction A to be finished, so the row gets unlocked so it can actually read data from that row. So now transaction B is waiting. So we can go ahead in transaction B and let's say the application does its thing, and then we update the row. So we do an update statement. Now, if I commit this transaction, you will notice then that now we don't have any background tasks, which means that the select statement in transaction B is actually finished. So it was able to get the data from the balance table from that specific row because it's not logged anymore. And the result is 0. So because Postgres gave time for transaction A to finish, the table returned the correct value, or Postgres returned the correct value for the balance. So now if we actually run the logic in our application, we will see, the application will see that the balance is 0, so we shouldn't run this update statement. And now you can roll back the transaction or do something else. So that's the idea. So this is how select for update works. This is an approach that is outlined in multiple Postgres books, and it's a recommended solution. At the same time, there are also situations where it's not going to work. For example, if you're working with foreign keys, because if you run select for update, then it's gonna lock that specific row, but it's gonna also lock every insert statement on other tables that are referencing this row. So for example, let's say you are trying to update this row in this example, and there's a foreign key in this row, and you are inserting data into another table which is referencing this row. So that insert statement will need to wait until you are finished with this transaction, and that can be a problem. So in that case, it's not a good solution, but otherwise it's a solution that you might want to consider. With that said, thank you very much for watching. If you have questions or opinions about this, you can use the comment section below, and I see you in the next video. Bye.